my recording here. So, speaking again about beams and cranes, what we took so far was how to just get the reactions at these supports. Okay, but you didn't know what's happening within the member itself. You didn't have any idea about what's happening inside this thing. So, also in order to understand the behavior, we need to imagine what's happening. So, this is what we call a simply supported beam. Okay, because it's supported only on two supports and it's only one bay. However, this is what we call two spans. Two spans. It's continuous from one side. Here, we could have multiple spans, 3 spans, 4 spans, whatever the number of spans. This is fixed-ended. This is having an overhanging cantilever port. This is a cantilever on its own. And each one of these, you can imagine, will have its own shape of deflection. But what causes this deflection? What will cause a beam to deflect? Aslan, from the first place. Imagine. And if I have a beam like this, loaded like that, how will it deflect? So it will deflect like this. مش كده؟ So what causes this deflection? Do you agree that it will deflect like that? Do you agree? Right. What will cause it to deflect like that? That's a very important concept now. What will cause this deflection? So the point is that if I take a section within this beam, what will I see? I will see that this thing wants to bend, actually. And if you recall the method of sections when we discussed trusses, when you took a cut in the members, what was an internal force became an external force. صح? So now, if I'm taking a cut and I'm looking here, and I'm drawing this part like that on its own, what will I see is that I'll have my reaction here, I have my loads here, but additionally there is something here that was not seen before. It's now there. Like, to make it stable, to make this portion stable on its own, what can I just leave it and it will fall? No. So there must be an internal force that keeps it apart. So this internal force acting like this, which is in the same direction of this thing, we call it the shear force. Why do we call it shear force? You know what's the term shear in Arabic? You know what's the term shear in Arabic? What's the translation? Al-qas. Okay? So what's shear? What's shear? Simply speaking, take a whole thing. Simply speaking, what's shear? What's shear? If I hold a piece of paper like this, you have to make it a beam, I'll make it like this. Okay? And it wants to fail. Look. This is one mode of failure. That it's cut like that. So this is the shear force. What's the other mode? That it bends like that. So this is the bending mode. So remember these two. So this is what we call the shear force, the V. And there is a moment here that we call, this is M, this is the bending moment. You guys will have that stuff for the coming month or something like that. Okay, these two. What we'll be doing is that we'll be watching the variation or tracing the variation of the bending moment and the shear force all over the length of the beam. Okay, we'll trace that. Right. So let's look maybe at something like that. Maybe that shape will help a little bit in making you understand what's happening here. So again, these are the items that will make it stable, to make it existing. It's not falling. Right. There is something very important you need to understand. People agreed on a sign convention for these guys. Okay? Sign convention is very simple. Sign convention is very simple. So, again, we said that shear force, when I said we are talking about shear force here, we talked about something going up and another part going down. Physically speaking, how does this happen? Again, if you look at my hand, and I'm tearing this paper, one hand is going up, the other is going down. So shear by definition, shear stress, shear force, any shear, it's something going against something else. Whether who's up, who's down, that's not the concept. There's one up, one down. Okay? Fine. However, in terms of moment, the directionality is making a very big difference. In terms of moment, if I get this piece of paper and I'm bending it like this, it's totally opposite to doing that. Totally opposite. Why totally opposite? And this is why the direction and moment is very important, especially for us in our application. Because if I'm taking a cross section here in this beam, what's down is under compression and what's up is under tension. But if I reverse the bending moment, what's down is under tension and what's up is under compression. But that's why this directionality is very important. If I'm talking in the language of exams, you will lose marks if you reverse the direction. Why is that? Because at the end of the day, if you are talking about drawing or designing a reinforced concrete beam, that means that instead of placing the steel down, you will place it up. It's reversed. Okay, so we are reversing everything. So that's a catastrophe. Okay, fine. So people agreed on sign convention, a very nice sign convention. So if I'm doing this, if I'm bending this way, okay, we said this is a negative bending. If it is up, it's a positive bending moment. What does that mean, physically speaking, for us? So again, if I'm going back to my drawing, and please we need to focus away here. So here I'm taking my cut. After south. Okay? So if I'm taking my cut, I'll try to work here. And I'm looking there. This is my cut. What's cutting it? So this thing is telling me that if you are taking a cut and looking left this way is opposite to right this way. Okay? This is negative. If it is this way and that way, this is positive. But what's the easiest way to remember this thing? As simple as that. This guy's sad. That guy's smiling. Because you are late. But again, I repeat. If you are studying a beam, and this beam at one piece as one rigid body, we dealt with the beam as a rigid body, we got the reactions. طيب, what's happening inside the beam? You don't know what's happening inside the beam because you're dealing with the whole beam as a rigid body, صح? طيب. But if we take a section, a cut, similar to what we have done in the truss last time. If we take a cut, a section at anywhere between the supports. Okay? Now I'm looking at a part of the beam. صح? طيب. This part of the beam, I made a cut. So when I'm cutting, there was something that was not seen before. I am seeing it now, which is what I had here as internal actions, an internal force called the shear force, and an internal moment called the bending moment. Okay? These are the things that are keeping it stable. Yeah, these are the two things that are keeping this beam stable, or else it will fall off. Hell, if that stuff is not existing, well, if I remove these two, this thing will fall. As simple as that. If there is nothing to hold it, look here, look at my hand. If there is nothing to hold it here, it's falling. Okay? بس مش أي حاجة. هي دي إيه؟ حاضر هنشتغل. You will see it with the example. Okay? You will see it with the example. طيب. المرة الجاية ولا مرة واحدة يعني إيه؟ يعني هو بيم واحد. حاضر. هي موجودة في النص مع الناحية دي وفي النص مع الناحية ولا في النص؟ يعني في واحدة هنا واحدة هنا ولا واحدة؟ Supposedly, if you do the same calculation from the left hand side, you'll get exactly the same result as the right hand side. So it's the same one. So actually, this is one of the checks that we do, is that you take a cut and you look left and you look right and you reach the same answer. So this is something that we'll do. Okay? طيب. Let us do the example now. Maybe things will be clearer inshallah once we do this example. Okay? معرفش اشتغل هنا ولا اشتغل هناك. لا كده. Okay, I'll do the example. لا كده مش هنجيب. I'll do it there. So, again, what we are having here is, simply speaking, a cantilever. This cantilever has a fixed support here, has a load here, or has this thing, this distributed. Fine. I'll show you something here. I'll show you how I'll do this the easy way. You'll feel that it's not easy على حاجة when I do it. Okay? But when I show you what he's doing, how he's doing it in these slides, you will discover that what I'll do now is the easy way. Okay? What I'll do is that I'll trace this thing. We need the internal force. We need the internal force. First thing, we need to get the reaction. صح? But wait, not always. We will not always need to get the reactions. Maybe you will need it, maybe not. But if I take a section and I look right, sorry, left, actually I don't need the reaction because there is no reaction there. But if I'm taking a section and looking right, I must get the reaction and see. صح? But let's keep this reaction thing on the side and do it without the reaction. So, this is 2 kips per feet, and this is 8 feet, this is 6 feet. We said we need a section, but where do I need the section? Where? So at A, or between A and B, or between B and C. And what about what's happening between A and B? What we need here is what? We need to draw something called the shear force diagram. SFD. Okay? This is getting us the relationship of the shear force all over my axis, over my horizontal axis in this case. Right? Good. So if I look at this diagram, look معايا. If I look, I forgot to mention that the sign convention for the shear force, we are taking a cut, and looking left, what's up is positive, but if you're looking down, what's up is negative. So here, this is the positive case, and this is the negative case. So that's why it's always easier to look, take a cut and look left. هتشوفي دلوقتي. So if I take a cut before A, is there anything? How? So just before A, that's a 0. صح? What if I take a cut just after A? I only see A. So this is my free body. Just a force going down. بس خلاص. So it's هنا I see a drop by negative force going down. Okay, ده اللي أنا بقوله. تمام؟ طيب. If I take a cut anywhere between A and B, here, here, will I see anything different than that force?
No.
So the force is constant until I meet point B. حلو؟ معايا؟ Do you agree that when moving from B to C, the more I move towards C, the more is the force I'm receiving? Do you agree? Yeah. This is a uniform load. This is a rectangular thing. صح? This is a rectangle. So if I'm moving here, the more I move towards C, the larger is the area of my rectangle. Do you agree? But if I take a cut just before C, I'll see the whole خلي I'm looking a cut here and looking at everything. So what I'm seeing is what? I'm seeing the negative 4 minus 2 times 8. Do you agree? So this is equal to negative 20. كله نازل? Going down. Okay? So this is negative 4 and this is negative 20. And I'm not drawing this to scale out. This is negative 20. طيب ايه اللي هيحصل هنا؟ هو actually if you go and calculate this reaction, the reaction is equal to 4 times plus 2 times 8 اللي هو ايه 20. 20 came up. So here after C it's receiving the reaction and this thing is what? Closing. Making sense? Making sense. Because if you take a cut after C and look right, there is nothing, there is a 0, so it must go back to 0. Must go back to 0. It must close again. Right. So you understand this. You notice anything in terms of these relationships? When you are having nothing happening between A and B, nothing happening between A and B, you are actually having what? A constant shear force. صح? So this thing is obviously constant. Right. However, here gradually increasing. Do you agree that this thing is linearly increasing? Or linearly? The relationship here, this is a straight line. You wanna double check؟ شاكين في الكلام ده؟ حاضر طب اصبر. We'll double check that. حاضر.
عشان هي gradually
برافو عليك. It gradually changes. If you have any doubts, as simple as that.
عشان مثلا عند البوينت دي
Let's take a section here at the point in the middle.
هتبقى مثلا 2 times 4 مش 8.
برافو عليك. So if this distance is 4, so now if I'm taking a section here and I'm looking, I'm seeing negative 4 minus 2 times 4, not times 8. تمام. So this will become negative 12. أهو negative 12. So if you have if you plot here, this is negative 12 and this is negative 4. If you continue, this will be negative 20. It's a linear line. ركزوا معايا في القصة دي. طيب, let's look at its other sister, the bigger sister, the bending moment. The bending moment is one of the things that you must get out of here knowing it. طلع من هنا من غير ما تعرف. Okay? Let's check which one is better. So, again, خلي بالكوا بقى, we reached some kind of a rule in the shear force. Where do I do my cut? I'll do my cut after and before. خلي بالكوا. After and before each change in my load and each change in my geometry. Okay? يعني I did a cut before the load, I can zero. After the load, I can see my load. Then there is nothing between A and B, so it's the same thing. مش فارقة خلاص. Cut. Then I did a cut where before C and after C. And I drew my line. Okay? Fine. Now let's talk about the bending moment. Diagram. BM. Okay, we just double check that it's obvious. باينة الحمد لله. So the bending moment is even easier a little bit in doing it. Why is that? Because a moment is actually something at a point. You take a moment at a point. But if I'm standing at A and I'm taking a moment, I'm looking there, will I see anything? هواء, صح? So the moment is here. بس خلاص. طيب. So I'm standing at B. Ladies. هنا it doesn't make it because it's not a shear force. It's not a force that's before and after. It's a moment. The moment is taken at a point. So I'm standing at B. Standing at B. هنا.
ليه بي؟ ليه مش ايه او سي؟
هتعرف. اصبري بس. Okay? اصبري بس. We're standing there at B. Okay? And looking there. ما احنا عملنا عند ايه على فكره.
ايوه لا انا مش فاهمه احنا هنعمل يعني احنا على البيم هنعمل مومنت عند كل بوينت A و B و C مش احنا خلاص عملنا عند
at each change in load. خلي بالك the rule for the shear, focus now, the rule for the shear we said before and after each change in load and geometry. For the moment it is at each change in load and zone. عشان كده قلت
هنعمل
this.
الثلاثة.
Okay. Yeah. بس اصبري بقى. بس على فكرة this rule has one exception اللي هو before and after وهنتكلم فيه بعدين. In a very special case. Okay. طيب. At B, I'm looking there. انسي بقى اللي هنا ده. Look there. What will you see? 4 times. Is it sad or happy? Look here. Sad. برافو عليك. So, بصوا يا بنات. I'm seeing sad, negative. So this is negative 4 times 6. So this is what?
ليه بقى بدأنا بالساد؟ ليه ما بدأناش بالنيجاتيف؟
هو الحقيقة in a cantilever there is nothing happy. Unfortunately. معلش بادي معاكم حاجة نكد. Okay? So in a cantilever seriously والله يعني in a cantilever you will see now that in a cantilever it's always the case that the bending moments are always negative. Okay? We will see a simply supported beam إن شاء الله. لا هنا بقى مفيش اختيارات. Unfortunately here you don't have that freedom of choice. هنا this is خلي بالكم يا بنات خلي بالكم نقطة مهمة. You notice something here. I'll draw the bending moment the negative is up. أنا عارف إن هو يبدو غريب جدا. هنا in the shear force I drew the negative down and the positive is up. هنا I draw the bending moment the negative is up and the positive is down. Whilst ده حاضر هنيجي بس للمسألة حاضر اصبري معايا والله أنا عارف. There is a lot of question because I'm saying very weird stuff for you now. حاضر بس be a little bit patient and you will see why. We're talking about it. أو خليني حتى أقولها لك. Here, if you look at this arrow, where's the tail of the arrow? The tail of the arrow. Up. So, in terms of directionality, the tail of the arrow will be facing tension or compression? Tension, bro. So, okay, so when I'm saying the tail of the arrow here, this is something doing like that. Okay, you have a ruler. Ruler, طرف دستك. ruler. وبادي طبعا نشيل الاختراعات دي. حاضر، مفيش مشكلة. واشرح على الإزازة دي دلوقتي. لا ما تعمليش كده دلوقتي. لا. Okay. So, look at this bottom. So I'm bending it like that. Look here. This is the cantilever. My left hand is the fixation. Okay, I'm applying the force at point A now. Okay, أهو. This part is under tension or compression. The upper part is under tension or compression? Tension. The lower part is under compression. صح? This is exactly what a negative bending moment means. That the upper part is under tension, the lower part is under compression. We intentionally draw the bending moment this way to show the tail of the arrow. Where is it? Why is that? Because this is not only this is mainly in Egypt and in all of the previously British occupied countries. You find this in Egypt, you find it in India, everywhere. However, in North America, لا. بيرسموه the positive moment is up, the negative moment is down. If you go to this text and you look at it, you'll find it exactly opposite to what I'll be drawing here. حلو؟ تمام؟ Just different ways of drawing things. But the same values you'll find. تمام؟ طيب. So again, why do we do that? Because we do mainly reinforced concrete design. And we need to imagine where will I place my steel. So I'm always placing the steel in the direction of the bending moment. So this is why we are doing it this way. The negative is up, the positive is down. Okay? Right. So this is negative 24. How will I connect it? How will I connect these 2 points? Straight line ولا curve ولا طلع مرة واحدة ولا ايه حاجة؟ Let's do a nice exercise. Steps. طب خلينا نشوف. Simple as that. Take a cut. Midpoint between A and B. No. Look there. What will you see? Negative 4 times scale 3, which is negative 12, half of the negative 24. انا مين cut the log there. I'm calculating the moment.
لا.
So this is هنا this is the 12. So this is a linear relationship between this thing, the 0 and the 24. Did you notice anything?
المترس دي طالعه وهي
Okay? معلش بقول لك you will take some time to get used to that. This is why on purpose I finished the process in 1 week and I'm giving 2 weeks for beams and 2 weeks for frames because I know that this is a mind shift. It will take you some time to shift your mind from the regular sign convention, from the regular system to this. Okay? This, you guys need to study. This is serious. And it will get more serious. Okay? I'm not freaking you out. I'm telling you the truth. This is serious and it will get more serious. Okay? You need to study. لا سمح الله. You need to study. Okay? خلاص؟ معلش. نيجي على نفسنا شوية. خلاص؟ Okay? طيب. So, ladies, please. You notice something. Did you notice something here and here? This is constant, this is linear. And there was nothing between A and B.
كان عشان المومنت فيها
So actually, we are having a higher order. طب خلينا نستنى لغاية ما نشوف between B and C what will happen. So this is the moment at B. Let's take a cut here and see exactly and see. Look there. What will happen? We'll see the negative 4 times this whole distance, which is what?
هو دي كام؟
6 and 8. It's 14. يعني لسه دي. So this is negative 4 times 14. And that one is also negative. عايز اعمل كده وكمان. So this one will be negative 2 minus 2 times 8 times what? 4. Could somebody do the math here, please? 4 times the centroid. This is the 4. مالك انت مش في المود النهارده. صح حاجه كده. Okay. ايوه.
كلهم تايمز بعض صح؟
لا minus 4 times 14 and this negative 2 times 8 times 4. هو الحاجه كده هتبقى minus 4 times 30 ده تكتب على negative 120. صح؟ So this is a negative 120. Okay? The units here is kip feet. بصوا بقى. بصوا يا بنات. أنا عندي هنا this is the negative 120. And because this is a fixation, خلي بالك. If you go actually and calculate the moment reaction here, you will find it at 120 كده. The moment reaction at C, at the fixation, you will find it to be at 120. So this must be equal to the moment reaction. Okay? This must be equal to the moment reaction. اصبري بقى. What's happening here? Let's check.
لا عشان لحد الفور مفيش حاجة.
Let's check.
هو لحد الفور مفيش حاجة.
This section, the same section where we look here, this thing, I'll see 4 times what's that distance? But this is 4, صح? So 4 times negative 4 times 10, مش كده? And this is what? Negative 2 times 4 times the centroid, which is 2. So that's a minus 40, and this is a minus 16, so this is a negative 56. Negative 56. This is what? That's the parabola. What's happening here? I hope I'm telling you, it's obvious. It's a higher order. What happened? Look here, ladies. We had nothing happening between A and B. the shear force became a constant relationship. The bending moment became a linear relationship. هنا I am having a value between B and C, a uniform load. So the shear force is a linear relationship. The bending moment is a parabola. Actually, simply speaking, we can solidly say that the bending moment of x, خلينا نحط على M of x, is simply the integral of the shear force. The bending moment is the integral of the shear force. And actually the shear force is the integral of the load. Now we are increasing in the order. This is why it's higher order. This is why the so تعالوا نشوف. طيب let's do a check عشان نعرف relationship دي. Let's do a check. Calculate this area. 4 times 6 is 24. Okay. Calculate this area of this trapezium. What's the area of a trapezium? Oh. So here. So I'm talking. I'm having Q4 plus 20 over 2 times the distance, which is 8. Okay. خلاص. Plus. So this is a 96. حلو. Plus the 24 يديني كام؟ You get what I'm saying? So this area, this is actually the difference. This 96 is the difference between these 2 points. So this difference is negative 96. You get the point? What's happening? Okay? طيب. Am I telling you to use this thing? لا. I'm giving it to you to understand it. Don't go and use the area under the curve. ما تعمل كده. But you need to understand the relationships. You need to understand the relationships. Fine. Let's see how this guy solves it. Let's see how this guy solves it. So here he is actually dealing with it as a calculus problem. And he will take a section and take an equilibrium equation and get a relationship. He divided it into segments. يعني a zone called x1 between A and B, and a zone called x2 between B and C. He'll get us an equation for the moment and for the shear in x1 within x1, and another equation for the moment and the shear between B and C. Let's see here. So he's taking the first section. He gave you a relationship that m is equal to negative 4 times x1. By the way, this is the same thing here. I mean that here, if you plug in this relationship, when x is equal to 6, so 4 times 6 is 24. His equation is right. But he's doing it a little bit the more calculus way. Okay? Then, بعد كده بقى, لا, the equation became of higher order. Can you see? أهو. This equation is what? Quadratic. This is a quadratic equation. تمام? And he got an equation for V. And then he got an equation, an expression for moment. He's taken at an arbitrary distance of x2. So now he's 4 times 6 plus x2, and this is a negative, minus the load, which is 2 times x2, which is the distance, times x2 over 2. Then he got the moment. An expression, a quadratic equation. Plugged in the math, and he got, he took exactly the same point at the middle that I have taken, the 4 from B, and he got it to be exactly negative 56 as I got. You want my way or his way? Okay. Of course, you guys don't like equations. Tمام? So, but I thought that I must present both. You have the right to choose. Again, whoever wants to do this way, understand. And as they say, كل الطرق تؤدي إلى روما. Okay? So, then, so again, this is how this thing goes. Fine. Let's look at another example. Let's look at this example. He was a little bit kind with us now, and he gave us the reactions in this example. LA. This is a neoprene pad, which is one kind of the roller surface. Okay? I told you that this is used mainly in bridges. Okay? Fine. So, if I draw it here, and I do it my way, and then again, let's compare the answers. Okay? So, برضو, it's always a very good practice. Draw everything beneath each other. يعني draw the stuff one thing under the other. يعني حتى this is why one of the reasons I give you in my exams, you will solve in the same space. So you have the beam and draw the shear force beneath it and draw the bending moment beneath it. Why? This is to trace the points. This is easier for you and for me. Okay? So this has a load of 28 kips here. This is at a distance of 5 feet. You have another 5 feet, and then you will have a distributed load. عايزكم تركزوا في الحته اللي جايه دي يا جماعه. Okay? Of 4 kips per feet. Okay? Fine. So this is I, E, C, D. Okay? Look here. So this is 37. This is the reaction. طبعا I will not give you a reaction whether in an assignment or a quiz or an exam. Okay? This هنا for the sake of time we're using his example with his reactions. Okay? Right. Let's start with the shear force diagram. I'll trace everything here. What's the first thing I will see just after, يعني طبعا احنا بادئين هنا هيبقى فيه force. What's the first thing I will see just after the A? The reaction. So this is the 37th kip up. أهو. 37 kip. تمام? Then, what if I take a cut exactly here? هشوف ايه؟ I will see 37 minus 4 times the distance, which is 10 feet. ركزوا معايا قوي. هنا this is a negative 3. Okay. Do you agree? I'm taking a cut. I'm looking there. I'll see what 37 up minus 4 times 10. Do you agree? Because 37 is going up, the 4 is going down. Okay? Right. So this is a negative 3. أنا مصمم أقول negative 3. The negative 3 is here. So how will I connect them? Linear. What happened here? Let's cross the 0. Right. In an integration differentiation relationship, what does it mean to have an intercept? When I tell you that the bending moment is the integral of the shear force diagram, so what does that mean technically? That when the shear force is equal to 0, the bending moment is what? Either a maximum or a minimum. بالكأس صح؟ طيب خلينا نشوف هيحصل ايه. Okay? So then between B and C, is there anything happening between B and C? No, so it's constant. I received that's 28. So here هيبقى عندي negative 3 and then 28. So this is negative 31. صح؟ Then it's constant, Then it receives what? The 31 FF. It must always close. لازم خلاص؟ طيب. Good to go? لا مش هتروح لسه بندنج مود. Okay? So the bending mode. By the way, in a case like this is very nice. There are 2 points that I know. I know. If I'm standing at A, is there a moment reaction? If I'm standing at D, is there a moment reaction? And there is just air beside me, صح? So these 2 points, I know that they are zeros. That's a 0 and that's a 0, ده أكيد. For sure the bending moment here is 0. For sure the bending moment here is 0. يعني if you do give me any other value, that's a conceptual mistake. هنا في you're missing a concept يعني. Maybe you thought that this has an range as a fixation. في حاجة غلط. Okay. طيب. Then, if I take a moment at B, what will I see? I look there. I see what? Four. صح? But what's being happy and what's being sad? So I'm taking I'm taking this moment and looking there. What's happy and what's sad? Bravo. So the reaction at A is happy. It wants to go like this. But the 4 times the 10 times the 5 is sad. So here I'll see what? $37 times 10. This is happy, it's positive. 10, okay. Minus 4 times 10 times 5. So this is 370 and this is 200. So this is 170 hip feet. So I'll simply say, أنا هنا في البوزيتيف بنقسمه تحت في البندنج مود. So this is 170. ركزوا معايا قوي. hip feet. هقول لك كلام these. Does it look like this? Does it look like this? Or does it look like that?
هجيب بوينت في النص بس هو هيبقى كده.
Do we agree that because the relationship between the bending moment and the shear force is an integral relationship? So at a zero shear you must have a maximum in the bending or minimum حسب بقى local maximum or minimum. Okay صح؟ طيب يبقى we need to calculate the value دي في الحقيقة. We need to take a section here. Exactly. But do I know that this dimension? We can know it from similarity of strength. So if I tell you that this distance is x, so this distance is then minus x, do you agree?
أنا مش فاهمة احنا بناخدها فين.
At the zero shear.
مش
To get the maximum bending moment. Here we are obsessed by the maximum. Because this is the value that we use for design. Okay? Fine. So this is x. So by similarity of triangles to get the dimension, I'll simply tell you that x over 37 is equal to بالظبط صوت المنبه بتاعي بالظبط. Okay? X over 37 is equal to 10 minus x divided by هو ده كان كام؟ ده كان نيجاتيف 3 مش كده؟ نيجاتيف 10 minus 10 minus x over 3. حلو؟ therefore نودي دي الناحية التانية الناحية التانية 3x is equal to 370 minus 37x. Therefore x is equal to, I send this on the other side, 370 over 40. Okay? 370 over 40, this is what? What's 370 over 40? حد يحسب لنا؟ يطلع 9.25. 9.25? Okay. So, simply speaking, I'm taking a section at this distance that I knew that's equal to 9.25. طب تعالوا نحسب بقى الحسبة بتاعتنا. So, now, my new value will be very similar to this one. So now this is 37 times 9.25 minus 4 times 9.25 times 9.25 over 2. حد يحسب لنا حدوته دي بكام؟ بالظبط. Centroid, this is my new rectangle بقى. 9.25. Okay؟
يعني انت حتى في المومنت دي
أنا خدت حتة من الريكتانجل، ما خدتوش كله.
انا كنت فاكره ان احنا بناخد اللي هو resultant at the point فهتبقى
The resultant of the whole thing لا. It's the resultant of this portion. 171.125. Can you see it's slightly larger than 170?
يبقى هو هيبقى عامل كده.
يبقى هو هيبقى لازم كده. نمسح ده. نمسح ده. So it's this one. And this value is the value we're talking about. Okay? تمام؟ طيب. So what else do we need? We know this point, it's a zero, أكيد. So we only need this point. By the way, here it's easier to look at that other side in my bending moment. So this point is simply 31, smiling bardo, going up like smiling. 31 times 5, so this is 155. 50. This point is 155. So I'll see. But these are actually two straight lines, two different straight lines. Why are they two different straight lines? This is not a curve, ya jama'a. It's not a curve. This is a line, that's another line.
معلش هما when we took the moment at the zero shear ال A الرياكشن اللي عندها كانت negative.
Possible.
مش هي كده؟
اهو 27 times 9.25 اهو possible. Smiling.
مش هي smiling كده
اهو
negative.
ده smiling اهو.
كل ده positive بس ده positive ده negative.
This cut means that if you are looking right of your cut, counterclockwise is positive. If you are looking left of your cut, clockwise is positive.
أنا افتكرت كده.
لا. Okay? تمام? Okay. So this is how this thing will look like. تمام? Again, why are they two straight lines? Because this is having a slope of 31 and this is having a slope of 3. The slopes are different. They are two different straight lines. They are two different slopes. Okay? So again, the shear force is the slope of the bending moment. And the bending moment is the integral of the shear force. Okay? I know ladies, inshallah, you get out of this class وهتكلموا نفسكم في الشارع. Okay? خلاص? But don't worry. But it's a good sign. Yeah, لا, it's a good sign. That means your mind is good. You feel this thing? لا, your mind is processing something. That's good. You know? As long as your mind is processing, if your mind is not processing خالص في reservation. Okay? خلاص؟ Okay? طيب.